So you see that little 5G icon in the corner of your phone all the time, right? We hear it's supposed to be better, faster, the future. But it's one of those technologies that's talked about constantly. Yet, let's be honest, it's still pretty misunderstood. So that's the big question we're tackling. What is 5G, really? Over the next few minutes, we're going to cut through all the hype, all the confusion, and really get to the bottom of what 5G is, how it works, and yeah, why it's at the center of so much debate. Look, most of us just think of 5G as faster 4G, and you're not wrong. But the jump in performance is so massive that it enables entirely new things we couldn't even really imagine before. I mean, just look at these numbers. The scale of this upgrade is absolutely staggering. We are not talking about a small bump here. 5G is up to 10 times faster than 4G, with these crazy theoretical peak speeds of 20 gigabits per second. But speed is only half the story. The other revolution is latency. That's the delay before a connection even starts. 5G just slashes that delay, making communication feel, well, instantaneous. And that is the key that unlocks its most futuristic applications. Okay, so let's get grounded with the official definition. At its core, 5G is just the fifth generation of wireless technology. Simple as that. It's built on a global standard, which is what makes sure your device can connect all over the world. Every decade or so, we get a new G, and this is the one that's been rolling out since about 2019. But here's maybe the most important thing to understand. Not all 5G is created equal, not even close. Your experience with 5G completely depends on which of its three flavors or frequency bands you're connected to at that moment. Think of it like a road system. You've got low-band 5G. That's kind of like a country road. It covers huge distances, just like 4G, but the speeds are only a little bit faster. Then there's mid-band. This is the superhighway. It's that perfect sweet spot of great speed and good range. This is what most of us will be using most of the time. And then there's high band. Man, this is like an F1 racetrack. Unbelievably fast, with speeds that can actually rival the fiber internet cable coming into your house. So what's the catch with that racetrack level speed? Well, those high-frequency waves are, a bit fragile. They have a really short range, and they can't easily pass through walls or even trees. The solution is something called small cells. These are low-powered base stations that get placed every few hundred meters in really dense areas, like stadiums or downtown city centers. So we've covered the how, but the real excitement is in the why. I mean, why do we need this massive leap in capability? Well, it's because this is about connecting so much more than just our phones. The industry really sees three main promises. The first one is pretty obvious. It's about making our mobile broadband better, or EMBB. Faster streaming, better connections in crowds. But the other two, that's where the future really lies. One provides these ultra-reliable, super low latency links for mission-critical uses, what they call URLLC. And the other, MITC, allows for connecting a massive number of low-power devices. We're talking up to 1 million in just 1 square kilometer. And that massive connectivity is what's going to power truly smart cities. Just imagine a city where traffic lights, public transit, water pipes, the electrical grid, they're all interconnected, all communicating in real time. 5G is the nervous system that makes that kind of citywide efficiency possible by connecting billions of Internet of Things or IoT sensors, and of course, connected cars. Thanks to that crazy low latency, 5G allows vehicles to talk to each other and to the road infrastructure in real time, warning about accidents or hazards up ahead. Now, while fully autonomous cars don't require 5G to drive themselves, the technology is absolutely critical for things like remote teleoperations, where a human could actually take control of a vehicle from miles and miles away. And while you might hear about these far-off uses like remote surgery, a huge impact is actually already here: fixed wireless access. Carriers are now using 5G to deliver high-speed home internet, competing directly with the cable companies, especially in those underserved areas where laying fiber is just too expensive. Now, with any technology this powerful and this transformative, it's absolutely going to generate concerns and controversy.
So for this section, we're going to neutrally present the key debates, just as they've been reported in the source material.
Let's start with a scientific concern. Some 5G frequencies operate really close to a band that satellites use to detect water vapor for weather forecasting. The former head of NOAA actually warned that interference could bleed over and corrupt that data, potentially knocking down forecast accuracy by up to 30%. This has led to an ongoing international debate between regulators and meteorologists. And a very similar issue sparked a major conflict with the aviation industry. In the US, the C-band frequencies used for 5G are right next to the band used by aircraft radar altimeters, which are critical for landing in bad weather. The FAA raised serious safety concerns about potential interference, which led to that brief but pretty chaotic delay of 5G deployment around major airports back in early 2022. Beyond the technical issues, there's a huge geopolitical debate. Several countries, including the US and the UK, have restricted using equipment from Chinese vendors like Huawei in their 5G networks, citing fears of potential espionage. US intelligence agencies have warned that Chinese security laws could force these vendors to hand over network data. Now, the companies have consistently and strongly denied these claims. But this security issue remains a primary source of international tension around 5G. Of course, the most widespread public concern is about health. You've almost certainly seen claims online linking 5G to all sorts of health problems. So, what does the science actually say? So, the crucial point here is this. According to major scientific and health bodies like the World Health Organization, there is no established link between 5G and adverse health effects. 5G, just like all the cellular signals that came before it, uses non-ionizing radiation. Unlike ionizing radiation like X-rays, it just doesn't have enough energy to damage DNA. In fact, those higher frequency millimeter waves are even less able to penetrate your skin to reach internal organs. But that scientific consensus hasn't stopped misinformation. The rollout of 5G happened to coincide with the COVID-19 pandemic, and that created a perfect storm for conspiracy theories. These false online theories linking the two had very real and very dangerous consequences, leading to dozens of arson attacks on cell towers across Europe. So where do we go from here? Well, as you know, technology never stands still, and 5G is already evolving into its next phase. So, meet 5G Advanced, sometimes called 5.5G. This is the next step on the roadmap, and it's designed to be a bridge to the eventual 6G. It's all about making the network smarter and more capable, using AI to optimize performance, and boosting support for really demanding stuff like extended reality, or XR. And that brings us to our final thought. 5G isn't just an upgrade for your phone, it's a foundational layer for a new kind of society where pretty much everything is connected. It holds the promise of incredible efficiency and amazing new services, but it also raises really complex questions about security, privacy, and our reliance on this invisible infrastructure. The technology is here, but the question remains, are we ready for the world it's going to create?